Okay, welcome back. So now we're going to look into a few algorithms, and we're going to start with document clustering. Remember, last time we talked about how to represent a document as a vector. So we went through the representation as a TF-IDF vector. And the idea was that we can now represent a document in an n-dimensional vector space, where the number of dimensions corresponds to the number of terms. So the number of all the different words that we find across all the documents. So that was one of the first examples of how to work with a feature vector, a vector representation of an artifact. And in this case, let's assume we're going to look at documents. And then we talked about what you can do with it. For example, you can look at the similarity between documents by computing the cosine of the angle between two document vectors. And we also looked at how we can use this. Last time we talked about recommendation and search. And this time we're going to look at another example, which is analyzing large documents collections. So one use case for this is in investigative journalism. You often hear this in the news that there was some data leak, some data set of documents. And then typically before you read details about it, some news agencies go through all of these documents and then analyze them and try to find some insight. Because when you have something like 500,000 emails from Enron, that big Canadian company that went under, this is nothing you could just go through and read yourself. If you want to get some conclusions out of them, you need to analyze them further. You all know about WikiLeaks, so they often release millions of documents on different topics. And again, you cannot expect anyone to read them one by one. You need to have some kind of tool support, some kind of intelligence system, some AI support to make sense of all of this. More recently, the Cambridge Analytica scandal with Facebook, and one that comes up from time to time, the Paradise Papers regarding offshore investments. So you sometimes read in the news about audits to individual or companies that try to do tax evasion. So the goal here is to have an intelligent system where you can just sort of dump all of these documents, how many you have, hundreds of thousands, or maybe even millions of documents. And then before you even start reading them, you have some kind of automated pre-processing. So you have some kind of structuring, filtering, analyzing, and so on. Regarding a deeper analysis, a semantic analysis, we'll talk in the upcoming weeks about natural language processing. Here we do kind of a pre-processing step where we group the documents together, where we cluster them. So remember in the introduction, I talked about the different kinds of machine learning, and clustering falls into the unsupervised learning category. So in unsupervised learning, we don't give our output a label like cat versus dog or Tom versus Jerry. We just group them together based on some kind of similarity. So in the context of document analysis, this can be seen as a pre-processing steps, because you can then look into the clusters in more detail. And then you can analyze these subgroups further with additional methods, and some of them we're going to see later in the course. So what exactly are clusters? So a cluster is a collection of data points. And what we want is that all the points within a cluster are somehow similar to each other, and the points in different clusters are somehow dissimilar from each other. But as you can see from this example here, this can be a tricky question. There is, in general, no correct or wrong separation into clusters. So if you look at these points here, it's the same points. We could say that the points in the middle is one cluster, and these points around here are a second cluster. But you could also say you just split them in the middle somewhere, and one half is one cluster and the other half is the other cluster. So I'll come back to this point at the end, but it's important to understand that there is no single correct solution for clusters. So there are lots of different clustering techniques, and for example, the different techniques will handle this type differently. So one technique might generate clusters like this, and another technique might generate clusters like this. And here in this course, we are going to look at one clustering technique that falls into partitional clustering, and this is the so-called k-means clustering algorithm. This is a rather old, but very well understood, very efficient algorithm for clustering. So it goes back to McQueen from the 1960s. The input to the algorithm is a number of vectors in an n-dimensional space. So this can be anything. In our application case of document clustering, each element would be a document vector. For example, a TF-IDF vector. What you also need as input is k, the number of clusters. So k means generates as output k clusters. So if you give as input 10, then it will generate 10 clusters as output. So how does it work? First, you have to decide on this variable k. And well, in practice, this can be a bit of a challenge because you might not know how many clusters there are. So often you experiment with a couple of different numbers and see what happens. So after picking k, you pick k points from the data set, and usually this is done at random. And these are the so-called centroids, meaning the cluster centers. Then you look at all the other points and you compare them to the k initial centroids. And you find out which one is the closest, and this point will be assigned to the cluster with the corresponding centroid. You do this for all the points, and when you're done with it, then you recalculate the centroid as the average of the cluster. And this you do a couple of times, and you stop when between two iterations nothing changes, or if the change is so small that it stays below a certain limit, and then you stop recalculating the clusters. So let's look at this in a bit more detail. Let's say here we have our initial data points. So again, it's two-dimensional to make it easier to visualize, but it works in any number of dimensions. Now we decided for k equals 2. So the two red dots are the two initial clusters that we have. So the two initial centroids. Now we have to compute the distance between each point and the two centroids. There are different distance metrics, and here we are just using the Euclidean distance. So it's the square root of the square of the vector difference. And then you know for each point the distance to, in this case, k equals 1, k equals 2 centroid, and then you assign it to the cluster with the smallest distance. So these points here are all assigned to the cluster with this centroid, and the points here are assigned to the cluster with the other centroid. So let's do this in a few iterations. So again, we are picking, in this case, we have, again, 2D vectors. We have now k equals 3, and we pick these points as the initial centroids. Now we compute the distance of each point to the 3 centroids and then assign them to one cluster each. So now you can see that the points here were assigned to this centroid, the points here to this one, and the blue ones to the third centroid. Now you have your clusters fixed, but now you want to compute the average of all of these points. And same here and same here. So you can see that the average point is going to change. It's not going to be here as in the initial assignment. It's going to move. So the center of the cluster is going to move into the new position. And now we have new centroids. Yeah, they moved somewhere in here. Now you repeat, you again compute the distance of all points with the new centroids. And then you can see that some of these points are now closer to a different centroid than they were before. Look at the green one. Now the distance here is bigger than the distance here. So after doing all of this recalculation, a number of points are going to change. And then because the points in the cluster changes, the centroid, the center of the cluster also changes. So this moves again, and then you repeat, and you repeat this until the clusters don't change anymore. So that's it. And to get a feel for the algorithm, there is an exercise on the worksheet, task number 2. And to see an example with more points, nice animated example, have a look at this video here. And after you're done with the video, go through task number 2, post your solutions, and I'll see you in the next lecture part.